Hello, welcome to Sound and Image Video 2. In this video we're going to look at how color is represented in an image and how it can affect the size of the image file. Images, like everything else on a computer, are stored in files as a sequence of binary digits. Let's look in more detail at how a color can be turned into binary. Let's imagine you're looking at a digital image on your phone or computer screen. It might be a picture of your favorite game, a cute pet, or a beautiful sunset. But have you ever wondered how that picture is actually made? Well, it all comes down to color, and the way digital images use three main colors: red, green, and blue, also called the primary colors of light. By mixing these three colors in different amounts, we can create any color. It's a little like mixing paints, but instead of using brushes, we adjust how bright each of the colors is to create new ones. The brightness of each color is controlled by bits, which are like tiny switches in a computer. The more bits you have, the more precise your control is over the colors. For example, if you have a binary number made of 8 bits for each color, you can represent 256 different shades of red, green, and blue. So, using all three colors, that's a total of over 16 million different colors. Let's use an example to show how RGB works. Say you want to create a bright purple color. In RGB, that might be represented as 128 for red, 0 for green, and 128 for blue. This means you're mixing red and blue light at about half brightness each, with no green. If you wanted to make this purple darker, you'd lower the red and blue values. For example, you might change it to 64 for red, 0 for green, and 64 for blue. Another example could be making a bright turquoise color. To do that, you'd mix green and blue light. In RGB, this might be something like 64 for red, 224 for green, and 208 for blue. This gives you a vibrant mix of green and blue, but only a little red. Now, let's talk about image size. The size of a digital image depends on how many pixels it has and how many bits are used for each pixel. For example, imagine you have an image that's 1000 pixels wide and 500 pixels tall. That gives you 1000 multiplied by 500 equaling 500,000 pixels. If each pixel is represented using 24 bits, 8 bits for red, 8 bits for green, and 8 bits for blue, the total size of the image would be 500,000 pixels times 24 bits equaling 12 million bits. Now, let's convert that to bytes and, since 8 bits equals 1 byte, this would be 12 million bits divided by 8 and equal to 1,500,000 bytes, or 1.5 megabytes or MB. So, if you want a high-quality image with lots of detail and colors, you're going to need more bits and pixels, which means a bigger file size. On the other hand, if you want to save space on your device, you'll need to use fewer bits and pixels, but the image won't look as sharp or detailed. It's all about finding a balance between how good you want the image to look and how much space you have to store it. And all of this magic happens by just adjusting red, green, and blue light. And that's it. You now know how color is represented in an image and how it can affect the size of the image file. If you enjoyed our content, please like the video and subscribe. It really helps the channel grow. See you in the next video.